Page 23. Let's continue with asymptotes. We have a question. 4x cube 3xy square minus y cube plus 2x square minus xy minus y square minus y 1 equal to 0. So you see, this is a cubic in x and y, while in x cube and y cube are present. So there will be no asymptotes parallel to either axis. Now for oblique asymptotes, you have to see what is phi 3m, phi 2m, phi 1m, and so on. You see, these are the terms having degree 3. These are the terms having degree 2. There is no term having degree 1. Now, we can write it is a cubic in x and y, where x cube and y cube are present. So, no asymptote parallel to either axis. To find the oblique asymptotes, we have, actually we assume y equal mx plus c as an asymptote, then we substitute here and we get these things. Now the method is, we have phi 3m. These are the terms which has degree 3. In those terms we have to replace x by 1 and y by m. Phi 3m is 4 minus 3m square minus m cube, replacing x by 1 and y by m. Phi 2m, it is 2 minus m square. Phi 1m, it is 0, and so on. Now in order to get m, we have to choose phi 3m equal 0. To find m, put phi 3m equal to 0. This means 4 minus 3m square minus m cube equals 0, or m cube minus plus 3m square minus 4 equals 0. You see, m equal to 1 satisfies it. Satisfies this equation. So let me use synthetic division. 1, m cube, coefficient of m cube is 1, coefficient of m square is 3, that of m is 0 and constant. 1 into 1 is 1, 3 plus 1 is 4, 1 into 4 is 4, 0 plus 4 is 4, 1 into 4 is 4, remainder is 0. If it is the root of this equation, this will always be 0. We will get a depressed equation. One root is gone. 1 into m square plus 4 into m plus 4 equal to 0. This is known as depressed equation. Now what's m? You can write it as m plus 2 whole square equals 0, or m equal to minus 2 and minus 2. Remember once for all, when you will get repeated roots, you will not get c from ordinary minus phi 2m divided by phi 3 dash m. You have to use another c square by 2 factorial phi 3 double dash minus plus c phi 2 dash plus phi 1 equals 0. Okay. Now, so you have three roots, m equal to 1, minus 2 and minus 2. Now for m equal to 1. When m is equal to 1, your c is equal to minus phi 2m phi 3 dash m. What is phi 2m? Phi 2m is 2 minus m square. Minus times, right? Phi 3 dash, this is your phi 3. It is dash, derivative is minus 6m minus 3m square. Now your m is 1, so c is equal to minus 2 minus 1 minus 1 minus 6 minus 3. This is 0 upon something which is 0. So therefore the asymptote is y equal mx plus c, So y is equal to 1x plus 0 means y equal to x. You know this is an oblique asymptote. Y equal to x. This is y equal to x. This is neither parallel to x-axis nor parallel to y-axis. So this is an oblique asymptote. Now we have m equal to minus 2 and 2. You can see when m is equal to minus 2, c is minus phi 2m, phi 3 dash m. This is minus 2 minus m square minus 6m minus 3m square, as we have seen here. Now your m is minus 2. So it is minus 2 times, 2 minus plus 2 minus 4 divided by m is minus 2. So it is plus 12 minus 12. So this is 0 by 0 form. So whenever you have repeated roots, you will always get c in the form 0 by 0 form. So you will use another formula to find c. Now to find c, we use c square by factorial 2 phi 3 double dash c phi 2 dash plus phi 1 equal to 0. This is the actually phi n double dash, phi n minus 1 dash, phi n minus 2. This I have already written in previous notes. Now c square by factorial 2 is 2. Phi 3 double dash. See, this is your phi 3. This is your phi 3. This is your phi 3 dash. 6m minus. And phi 3 double dash will be minus 6 minus 6m plus c phi 2. This is your phi 2. 2 minus m square. So phi 2 dash will be minus 1 plus minus 2m. Phi 1 is 0 is equal to 0. So you have minus 6. You can take it outside. M plus 1 c square by 2. 6 you have taken, minus 6 you have taken outside, m plus 1 c square by 2. Then you can take minus here, c 2m plus 1 is equal to 0. Now what is your m? M is minus 2. This is 2 into 3. M equal to minus 2 gives minus 3. Minus 2 plus 1 is minus 1 c square minus c. You can take minus outside. You don't need minus here because minus is over here as well as here. So 3 minus 2 plus 1 is minus 1 c square plus c. Your m is minus 2. Minus 4 plus 1 is equal to 0. Or you have 3c square plus 3c equal to 0. Minus I have already taken outside. So 3 times c into c plus 1 equal to 0, which means c equal to 0 and c equal to minus 1. These are two values of c corresponding to m equal to minus 2. Therefore, asymptotes are y equal to mx plus c. M is same, minus 2x plus c, it is 0. And y is minus 2x and c is minus 1. So these are two asymptotes, oblique asymptotes. You have three asymptotes in total. Y equal to minus c, y equal to minus x, y equal to x, y equal to minus 2x, and y equal to minus 2x plus minus 1. Fine. Now there are so many questions. I will be forwarding questions to you for your practice. Now let me take partial derivative. Partial differentiation. Okay. See, if you already know ordinary difference regarding ordinary differentiation, you have y as function of x, one dependent variable and one independent variable. So you can find all the derivatives, all higher derivatives as well. But y is function of x, so you are differentiating only y in terms of x, But when z, some variable, is function of two other variables, x and y, z depends on two variables. Instead of one variable, two variables are there, then z is function of both x and y. You can always have derivative with respect to x as well as with respect to y. And with respect to x and y both, so many derivatives are there. Let me write. When we differentiate this partially with respect to x, we write it as del z by del x. In that case, this is nothing but this is derivative f dash xy. Okay, but you are treating y constant. Similarly, del z by del y. When you are differentiating this function with respect to y, this is again the derivative of the whole function. But in this case, when you are differentiating with respect to y, you are treating x constant. Again, if you have del z by del x, fine, this will be some function. If you will differentiate this again with respect to x, then this will be some function. But again, you have to treat, when you are differentiating with respect to x, you have to treat y constant. Again, and this derivative is denoted by del 2z del x2. Similarly, if you differentiate this function with respect to y, you will get del 2z del y2. Again, you are differentiating with respect to y, you have to treat x constant. Again, you can find you have del z by del x. If you are differentiating this function with respect to y, then this is known as del 2z del y del x. And if you have already partial derivative with respect to y and you are differentiating with respect to x, then this is del 2z del x del y. These two are equal only when function is continuous. Function is continuous. Otherwise, they are not equal. Means del 2z by del x del y is equal del 2z by del y del x. But then when function is continuous. Otherwise, these are not equal. Now, this is del z by del x. I am differentiating with respect to y. I have to treat x constant. This is del z by del y. I am differentiating with respect to x. I have to treat y constant. This is how we proceed. For example, if your z is x cube plus y cube. See, this is very easy. And let me write 3xy also. Let me differentiate partially with respect to x and y. Now let me differentiate first partially with respect to x, del z by del x. With respect to x, you have to treat y constant. Y cube is constant, y is constant. So this is x cube means 3x square, y cube means 0 because this is constant. Now 3 is constant, y is constant, and derivative of x is 1. So the derivative is 3 times x square plus y. Now, if I will differentiate z with respect to y, I have to treat x constant. So this is 0, this is 3y square. Now 3 is constant, x is constant, derivative of 3x with respect to y, it is 1. So this is 3 times y square plus x. This is how it goes. If this is 1 and this is 2, and if I will differentiate this again with respect to x, differentiate 1 partially with respect to x and 2 partially with respect to y. What I will get this with respect to x, del 2z del x2. With respect to x, y is constant, 3 is constant, so 3 times 2x. This is 6x. Now, del 2z del y2. This function with respect to y, it is 3 times 2y, 6y. Now, if I will differentiate first with respect to y and second with respect to x. Now, differentiate partially first with respect to y and 2 with respect to x. What I will get? Now, this is to be differentiated with respect to y. This is del 2z del y del x. You have to differentiate this function with respect to y. 3 is constant, derivative of x, y is 1, x is 0. Now, del 2z del x del y. you have to differentiate this function with respect to x. It is 3 into 1. Y is constant. So these are both equal. So this function is continuous. That is why these two are equal. This is page 24. Let me take one more example. If z is log of x square plus y square, this, see, z is function of x and y. Now del z by del x, log of the function, it is 1 by function, full function. Then derivative of the function with respect to x. So this is nothing but derivative of this function with respect to x is 2x upon x square plus y square. Del z by del y, log of the function, it is 1 by function. Derivative of the function, as I have already said. Then derivative of the function with respect to y, it is 2y, x square plus y square. Now let me find del 2z del x del y, del 2z del y del x, del 2z del x2, del 2z del y2, and so on. We can find anything. We can find del 3 also. Now this is 1, this is 2. In order to get this one, let me differentiate this first with respect to x. Now I will not write this. Now this is del by del x of del z by del x. Means that I am differentiating this function with respect to x. This is del by del x of this function, 2x upon x square plus y square. This is 2 times del by del x of x upon x square plus y square. Now this is u by v form. Simple. X square plus y square whole square. Now x square plus y square as it is, derivative of x is 1 because you are differentiating with respect to x, minus x as it is, derivative of x square plus y square with respect to x, it is 2x. So the solution is, this is x square minus 2x square. So y square minus x square upon x square plus y square whole square. Fine. Now let me differentiate this with respect to y. This is del 2z del x2. Now del by del y of del z by del y means twice del by del y of y upon x square plus y square. Again u by v form. This is x square plus y square whole square. Now x square plus y square whole square, derivative of y is 1. We are differentiating with respect to y, minus y as it is derivative of x square plus y square, partial derivative. With respect to y it is 2y. So the solution is x square minus y square upon x square plus y square whole square, twice. 2 is outside. This is y square minus x square, this is x square minus y square. You can also write it as twice minus y square minus x square upon x square plus y square whole square. If you will add these two, this and this, say this is 3 and 4, add 3 and 4, what you will get? Del 2z del x2 del 2z del y2 is equal to 0. Right hand side, this is positive, this is 3, this is negative, so solution will be 0. This is 4 instead of this. So you will add up right hand side, left hand side, this will be 0. Now let me differentiate first partially with respect to y. Del by del y of del z by del x is del by del y of twice x upon x square plus y square. You have to differentiate only with respect to, let me write 2x here, with respect to y only. So x is constant, 2 is constant. So this is 2x times del by del y of x square plus y square raised power minus 1. So this is it. 2x is constant. I have taken it outside. Derivative of this with respect to y. This is 2x, x square plus y square raised power minus 2 and minus 1 over here. This is say x raised power n x raised power n minus 1, and internal differentiation of the function with respect to y, it is 2y. So it is minus 4xy upon x square plus y square whole square. Okay, I have differentiated first with respect to y. Now let me differentiate 2 with respect to x partially. This is del by del x of del z by del y. It is del by del x of, what is del z by del y? 2y upon x square plus y square. Again 2y is constant because we are differentiating with respect to x. This is 2y del by del x of x square plus y square raised power minus 1. You are differentiating with respect to x, y is constant. So 2y minus 1 x square plus y square raised power minus 2, and differentiation with respect to x is 2x. So it is minus 4xy x square plus y square raised power 2. Del 2z del x del y. You can see these two are equal. Okay. Now let me take up the total derivative. Total derivative. Total derivative. You can find ordinary derivative with the help of partial derivative. You see, if your z is function of x and y, you can have dy by dx equal minus del f by del x divided by del f by del y. This is it. You know partial derivatives, you can find the ordinary derivative. Second derivative also. I will show one, you will do the rest. Now let z is function of x and y, and x and y are independent. Independent means they do not depend on any other function. Fine. Then what is z plus delta z? This is f of x plus delta x, y plus delta y. Okay. Now let me find delta z. This will be subtracting these two. This is f of x plus delta x, y plus delta y minus fxy. Fine. Now this can be written as f of x plus delta x, y plus delta y minus f of x, y plus delta y. I have subtracted f of x, y plus delta y. I will also add up same quantity x, y plus delta y minus f of xy. Doesn't matter because these two, if they are cancelled, you will get this thing only. Now let me combine these two and these two. This is f of x plus delta x, y plus delta y minus f of x, y plus delta y f of x, y plus delta y minus fxy. Okay, nothing. I have done nothing. Now let me divide this by delta x and multiply this by delta x. Divide this by delta y and multiply this by delta y. Now what is this? You see, you have y plus delta y, y plus, but here you have f of x. This is x plus delta x, means y is constant, x is changing. So this is nothing but partial derivative of f with respect to x, taking limits as delta z approaches 0. In that case, delta x will approach to 0 and delta y will approach to 0. Because z is function of x and y, When you are giving increment to z, you are giving increment to delta x also and y also. When you are taking delta z0, no increment to z, therefore there will be no increment to x, no increment to y. So this will be partial derivative of the function with respect to x, because x is changing, y is constant. And this delta x will be dx. Again, this will be, this is c, this is x, y plus delta y. So there is a change in y. So this is partial derivative of the function with respect to y, and this is dy. This is your dz. Okay, fine. Now, this is one. You will need it in your second semester also, because this is needed in solution of the partial differential equations. Now, if z is constant, your z is function of x and y. Z is constant means fxy is constant. Fine. Means you have only two variables, x and y, so you can find the ordinary derivative, because you don't have three variables, you have two variables only. You can have the formula. When z is constant, what is dz? Dz is 0. Therefore, I will get from 1, 0 equal to del f by del x dx, del f by del y dy, or dy by dx is equal to minus del f by del y divided by del f by del x. You can find it. Okay, this is 2. Now, let z is function of x and y. As I have taken here, z is function of x and y. But now let x is function of t and y is function of t. X is function of t, y is function of t, means z is function of t. Z is function of x, z is function of y. But x is function of t, y is function of t, means z is some function of t. So therefore I can find dz by dt, because I have only two variables. So now from 1 dz is equal to del f by del x dx, del f by del y dy. Now x is function of t, y is function of t, z is function of t. Therefore, let me write it like this. Actually, I don't have to write it like this. I have to do it over here. Your z is function of x and y. I have to divide both sides by delta t, delta t, delta t. Taking limits, I will get this thing. Z is function of t, I can find dz by dt, ordinary derivative in terms of partial derivative. Fine, this is 3. We need so many things. I will be providing some notes to you. Go through them. See. Okay, now one more thing. If you have a function fxy which is homogeneous. Now what is homogeneous function? A function, you can see the book, z equal fxy is said to be homogeneous if z can be written in this form, x raised power n function of y by x. I have shown you in our previous notes, if when I defined algebraic curve, I had taken phi n x, phi n minus 1x, or phi y by x, phi n minus 1y by x, so on. Those were all homogeneous. For example, if you have z equal x square plus y square, then this is a homogeneous equation of degree 2, because this can be written as x square 1 plus y square by x square. So this is homogeneous. And now I have a theorem which is known as Euler's theorem, which states that if z is xy is a homogeneous function, of degree n, then x del z by del x plus y del z by del y is n times z. This is very important and is very useful in your first semester as well as in your second semester also, because this is used for solution of partial differential equations. For example, if z is equal to x square plus y square, x plus y, find dz. You see, as per this Euler's theorem, dz is x del z by del x, y del z by del y. Now let me differentiate this. Now, if I will differentiate this partially with respect to x, this will be huge one. Then partial differentiation with respect to y, this will be again huge one. So what I will do, I can write this as x square 1 plus y square by x square. Then x 1 plus y by x. This is nothing but x raised power 1 function of y by x. Oh, n is 1 by Euler's theorem, x del z by del x plus y del z by del y is n times z. So you have this. You don't have to find partial derivative. Now see, let me suppose tan inverse. See, z is equal to tan inverse. Again same question, x square plus y square, x plus y. And let me suppose that I have to find dz. Then I have to, as per this, I have to find del z by del x and del z by del y. This will tan inverse will be 1 upon 1 plus this square. Then partial derivative of this with respect to x first, then with respect to y. I will not do that. I will write it as tan z is x square 1 plus y square by x square, x 1 plus y by x. So this is x raised power 1 function of y by x. This is a homogeneous function of degree 1. So by Euler's theorem, x del by del x of z, instead of z you have tan z, plus y del by del y of tan z is equal to 1 times z. Instead of z you have tan z. Fine. Now z is function of x as well as y. Z is x square plus y square, x plus y. So you can differentiate z partially with respect to x as well as y. So this is x. The derivative of tan z with respect to x, it is sec square z del z by del x. Because you can differentiate z with respect to x, this is function of x as well as y. Y sec square z del by del y of z is tan z. So you have x del z by del x, y del z by del y is equal to tan z by sec square z, which is sin z by cos z, and this is cos square z. So x del z by del x plus y del z by del y is 1 by 2. You can write it twice sin z cos z, because the question is you have to show that this, for this question, this is 1 by 2 sine of 2z. This is it. Let me give you some examples. U equal to cos inverse root x plus root y, x plus y. U equal to sine inverse x cube plus y cube, x square plus y square. Yeah. So, U equal to, okay, so this is fine. Let me stop here. Thank you.